In section 5.2, we're going to look at logarithms and exponential models. So we'll look at using logarithms to help us solve our exponential models or to see where two exponential models are equal. In section 5.3, we'll actually look at how to use logarithms to build a logarithmic model for real-world phenomena. Okay? But for now, we're going to stick with our exponential models and see how we can use logarithms to help us with those. So before we do that, I want to do a quick review of exponential functions. So we have our two types. Y is equal to AB to the x, which is our standard form. And then y is equal to AE to the KT, which is our continuous representation. So the initial amount for both of these is that letter A. Okay. And that will be the starting amount, no matter which version of this you're using. Our growth factor for the standard one is B, which hopefully we all remember is 1 plus R, but if not, this is why we're reviewing. And then for the continuous, our growth factor is E to the K. Our growth or decay rate for the standard is given by the letter R, and for the continuous by K. And assuming that A is greater than 0, okay, so A is positive, we know that our function is growing if R is also greater than 0, and what that also means is that B is greater than 1. Okay, so our formula is B is 1 plus R, and if R is bigger than 0, B has to be bigger than 1. Okay, and similarly on the continuous one, if K is greater than 0, we'll get growth. If K is less than 0, then we're going to see our function start to decay. And on the standard form, if R is less than 0, what that does is it puts B between 0 and 1. And that's where we know that we have our decay. All right, so what we're going to do is we're going to convert between these two formula types, so between the standard form and the continuous. And we'll fill in this chart down below. So the chart has the standard form, the continuous form. It asks us for the growth or decay rate per year, which is R. And the growth or decay rate continuous per year is going to be that letter K. And so we'll fill in the missing box. In the case of this first line, we were given the continuous version. So let's go ahead and figure out how we would get this into the standard form. We know that B is equal to E to the K, which means that's E to the negative 0.04. And we can calculate that pretty quickly here. So E to the negative 0.04 gives me about 0.9608. Okay. And then I can find R. I know that R is B minus 1 if I rearrange this formula. So that gives me approximately 0.9608 minus 1, which is about negative 0.0392. Okay, so our growth or decay rate per year, our R, is a negative. And I'm going to just go ahead and convert this to a percent. You can certainly leave it as a decimal if you want. But negative 3.92%. And our K is actually given to us right here, and that's negative 4%. And then to convert this to standard form, I get Q is equal to, that A stays the same, so I get 6, and that's going to be times 0.9608 to the T. Okay, number 2, I have a standard form. Q is equal to 5 times 1.2 to the T, and I'm going to work on getting this continuous form. So let's start out by finding R. So R is B minus 1, so 1.2 minus 1, which is 0.2, or 20%. So I can fill this box in down here on the table. So it's a positive 20% here. And then I need to find K. So I do know that B is equal to E to the K. Okay, so we can see that up here. And that means 1.2 is E to the K. And I'll apply that natural log to both sides. And the reason I'm choosing natural log is because, oops, I should say natural log of E to the K. Sorry about that. It's because ln and E are inverse functions. And so when you compose two functions that are inverses together, you're just going to get this input back up. So K is equal to ln of 1.2. so that is going to be, ln of about, it's going to be approximately 0.1823. So that gives me about 18.23%. And so Q is going to be, I get that same A again, so 5 e to the 0.1823 t. All right, last one, number 3, Q is equal to 10 times 0.91 to the t. So I would like you to try this one out all on your own. See how you do with it. All right, so let's see if we get to the same place that you got to. 0.91. So R is 0.91 minus 1, which gives me negative 0.09, or negative 9%. And I know that 0.91 is equal to e to the k. So ln of 0.91 is equal to k, which gives me approximately, let's see, ln of, okay, so negative 0.0943. Okay, or approximately negative 9.43%. And that means our formula here is Q is equal to 10, the same A again, e to the negative 0.0943 t. All right, so hopefully that gives you some insight into switching back and forth between standard form and continuous.